So today we're going to be answering the question, find the equation of the tangent touching the circle at -3 and -4. Okay, so this is the point here. This is where the tangent is going to go through, -3 and -4. The first thing we need to do is to look at this radius here, to draw a radius between the center of the circle and this point here where the tangent is going to go through. And we need to find the gradient of that radius, and I'm going to tell you why in a minute. But we need to find the gradient, and so the distance in y is going to be 4, and the distance in x is going to be 3. So this gradient of this line here is 4/3, and it's a positive gradient because it's going upwards, it's going uphill. Okay, so why do we need to work out the gradient of the radius? Well, it's got to do with one of the circle theorems, which is that the tangent is always perpendicular to the radius at the point of intersection. As you can see, these make a perpendicular angle with each other. Okay, so we've got the radius, which is a gradient of 4/3. How are we going to find the gradient of this tangent over here? Well, to find the gradient of a perpendicular line, you take the gradient of the first line, just swap the fractions around, change it from positive into negative or from negative into positive. That's called finding the negative reciprocal of the first gradient. Okay, so the gradient of this tangent is going to be -3/4. Okay, this is positive 4/3, and this is going to be -3/4. That's how we find perpendicular gradients. So we now have a point that the tangent passes through. It's told us there that we want the tangent passing through -3 and -4. We have the gradient of the tangent. We now have enough information to work out the equation of this line, the equation of this tangent. Remember, we use y equals mx plus c, and all we do is where we see the m we plug in the gradient, and where we see the c we plug in the y-intercept. So we've got the gradient. All we need now is to find out the y-intercept, and to do that we're going to substitute some values in. The x value here that it passes through is -3. The y value is -4. Remember, this is the x value, this -3, and this is the y value, this -4. So I have those two values here. I've also got the gradient, which is -3/4, which we've worked out already. Now I'm just going to plug these values into the formula here to try and find out what c is, because then I'll have m and c, and I'll know the equation of my line. So this is what it's going to look like. I've plugged these values into the formula y equals mx plus c, and what I get now is this. Okay, hopefully you can see how I got there. I multiplied these two together, so I did -3 times -3, which makes 9/4. So I've got -4 equals 9/4 plus c. The next thing I'm going to do is I'm going to try and rearrange that to work out what c has to equal. So I've kind of skipped a step. I've moved that 9/4 onto the other side of the equal sign. It's gone from being 9/4 to being -9/4. And what I've done is I've taken 9/4 away from both sides. So I've taken 9/4 away from this side to cancel that out. So I've got to take 9/4 away from this side as well. So I've got -4 minus 9/4 equals c. So that's basically the same as -4 minus 2¼ equals c. And if you don't understand that, I think you need to revisit adding and subtracting fractions and mixed numbers and that kind of thing. So what I'm left with is c equals -6¼ and I now have m, the gradient, which is -3/4. I've now got c, which is -6¼ so I now have the equation of this line over here. It's got a gradient of -3/4. we've worked out that the y-intercept is going to be minus 6 1/4, and that looks about right. That looks like it's going to be about minus 6 1/4. So we know that we've got it correct. We've worked out the equation of the tangent. The first thing we did was we worked out the gradient of the radius. Then we understood that the gradient of the tangent is going to be perpendicular to the radius. So if this is perpendicular to the radius, if this is 4 over 3, this is going to be minus 3 over 4. Then we substituted into y equals mx plus c to work out c, and we've worked out that c is minus 6 over 4. So the equation of the line is y equals minus 3 over 4x minus 6 1/4. It doesn't stop there. You can be asked further questions such as, where will the tangent cut through the x-axis? And in order to get this, you need to understand that all the way along this x-axis, the y value is always 0. The second value in your coordinate is always 0. So for example, that's 3 and 0, that's 2 and 0, that's 1 and 0, minus 2 and 0, minus 3 and 0, etc., etc. So wherever it cuts across the x-axis, which is going to be somewhere over here, if we were to extend our axes, the y value is going to be 0. Okay, so let's figure out how we're going to do that. We're going to make this y into 0 and see what x has to equal when this y is 0. Okay, so we've got 0 equals minus 3 over 4x minus 6 1/4. We now need to rearrange. We can add 3 over 4x to both sides, and that minus 3 over 4x will disappear, and it'll reappear on this side. And then we go through the steps. I've changed that from minus 6 1/4 into minus 25 over 4, just to make it easier to work with. I can multiply both sides by 4 to get rid of that fraction. Remember, that's divided by 4. So I can multiply both sides by 4. And I'm left with just 3x equals minus 25, these top numbers here of the fractions, because I've gotten rid of the denominators. Then I can divide both sides through by 3. So I'm left with x equals minus 25 over 3, which is minus 8 1/3. And that looks about right. It looks like that line's going to cut through the x-axis at about minus 8 1/3. Always check that your answer looks about right, it looks reasonable, and then you know you've done it correctly. So we've answered those questions. Now you can have a go. You can pause the video, try to work out the equation of the tangent touching the circle at 4 and 3 using the method that I've just used. So you can pause the video, and after that I'm going to go through how to do it. Okay, the gradient is going to be the gradient is going to be 3 over 4. How do I know that? Well, this 4 is the distance in x. So to get from the center of the circle to the edge, I've got to go across 4 and up 3. That's what this coordinate means. So the distance in y is 3, because that's how far I've gone up according to that coordinate over there. The distance in x is 4, because that's how much I've gone across. So the distance up is 3, the distance across is 4, the gradient is 3 over 4. So the gradient of this tangent, which is always perpendicular to the radius, is going to be minus 4 over 3. So now I have the gradient, I have the coordinates it passes through, I have an x value and a y value. So that's the information I have. Using y equals mx plus c, I can then work out what c has to be by substituting these values in. So I've gotten the x value from that coordinate that it passes through. I've gotten the y value from that coordinate that it passes through. I've got my gradient. Okay, again, I've got to now multiply these through, and I end up with this. I rearrange to that, and then I'm left with 8 1/3 equals c. So I have the equation of the tangent now. Y equals minus 4 over 3x plus 8 and a third. Where will the tangent cut through the x-axis? Again, I've put the grid for you now so that you can make a little bit more sense of it. The grid wasn't there earlier because you won't always be given the grid. Okay, where will the tangent cut through the x-axis? Where y is equal to 0. So we make y equal to 0. We rearrange. We get rid of that minus 4 over 3x by adding 4 over 3x to both sides. We get this, then we get this, then we get this. Hopefully you can understand all the steps we've taken. And then we get that. And that looks about right. It looks like that tangent is going to go through the x-axis at about 6 1/4. So we know we've got that right. So just to recap, finding the equation of the tangent, always find the equation of the radius first. Not the equation even, just the gradient of the radius. Then you use your rules of perpendicular lines to find out the gradient of the tangent. We use our y equals mx plus c to find out the equation of the tangent, and then we can do things like finding out where the tangent is going to cut across the x-axis. We know where it's going to cut across the y-axis. That's going to be 8 1/3, because that over there is the y-intercept, and that looks about right as well. That looks like about 8 1/3. Okay, so hopefully that's been useful to you, and good luck with your maths.